Welcome back to Frequency Online Math. So we'll be solving this question. So we are still under standard normal distribution, right? So we have suppose the lifespan of an electrical component is normally distributed with mean of 5 hours and standard deviation of 4 hours. Find the probability that the components will last between 2 and 12 hours. I greater than 15 hours. I less than 12 hours. IV between 8 and 12 hours. V exactly 15 hours. So write our solution. So find our mean first. Our mean is what? 5 hours, right? Then our standard deviation is what? 4 hours, right? I know that Z, we assigned a random variable Z for normal standard distribution, right? Instead of X, we call it was Z. And Z is equals to X minus mean all over standard deviation. This X is a function of what? Z, right? So we are going to be having representing this between 2 and 12 hours will be 2 less than or equals to Z less than or equals to what? 12. So we'll be having what? We'll be having P of Z, sorry, P of what? Our X is now what? 2. 2 minus the mean, which is 4, all over standard deviation is what? What is our standard deviation for, right? Then is less than or equals to Z, less than or equals to X now is what? 2 minus the same 4, right? Sorry, our mean is 5. Our mean is 5. So 2 minus 12 minus 5 all over 4. So we're having P will be 2 minus 5 will be minus 3. So when you subtract it, minus 3 divided by 4 will give me minus 0.75 is less than or equals to Z, less than or equals to 12 minus 5 is 7. 7 divided by 4, 1.75. Are you there? So what are we going to do? We draw our curve. So this is our center. This is the center of the curve. This is the center of the curve. So there's our origin, right? Minus 0.75 is somewhere here. So and 1.75 is somewhere here. So where are we looking? What are we looking for? We're looking for the area under this shaded portion. So that's what we are looking for. Area under this shaded portion. So how can we find the area under this shaded portion? So look for P of what? Z is equals to 0.75 plus P of Z is equals to 1.75. When we add two of them, we get the area under the curve. So P of Z is 0.7. So we look for 0.7 under 5. 0.7 under 5 give me 0. 0.2734 plus 1.7 under 5. 4 is 0.44599. So when we add the two, we are going to have 0.2734 or 0.4599. We are having 0.7333. I hope you can see it well. So we'll be cleaning the board to solve the II, which is greater than 15 hours. So we are going to clean the board and solve it. Let me pause. So for greater than 15 hours, representing it will be P of Z is greater than 15. As simple as that. So we are going to have P of what? Our X is what? 15, right? We have 15 minus our mean is what? 5 all over standard deviation 4. So we are going to have what? 10 over 4. P of 10 over 4. Are you there? 15. So let me divide. And so we're having 2.5. So it will be P of Z is greater than 2.5, like that. So if you like, you can still put this thing like this. You can still put it like this so that P of Z is greater than 15 minus 5 over 4. So which is equals to P of Z is greater than 10 over 4. So which gives us this. If you like, put it like that. So now I'm drawing our curve. So here's our curve, right? This is the origin, right? So we are looking for 2.5. So 2.5 is somewhere here. So greater than. This is our curve, right? So 2.5 is somewhere here. So greater than 2.5 is, we are looking for this side, the area under this curve. That's what we are looking for. So it's very simple. So it will be 0.5 minus P of Z is equals to 2.5. As simple as that. So we have 0.5 minus, we look for 2.5. 2.5 under 0 is 0.4938. So you do 0.5 minus 0.4938 to give us 0.0062. So that's the answer for the second one. So let's solve the third one. Let me clean the board. So less than 12 hours. Less than 12 hours. So P Z is less than 12 hours. So we're going to be having P of Z is less than 12 minus our mean is 5 over 4, right? So it will be probability of what Z is less than 12 minus 5 is what? To be 7, right? 12 minus 5, sorry, 5. The 7, yes. Divided by 4. 1.75. 1.75. So that's the value. 1.75, right? So we just draw our distance curve. 1.75 is somewhere here. So which is we are talking about less than, so this is the place concerned. place we are looking for. So here is 0. So we are going to be having what? Um, 0.5 for this side, then plus probability that z is equal to 1.75, and to 0.5 plus. Let's look for it in normal standard table. 1.7 under 5, 45.99, 0.4599. So when you add the two together, you get 0.5 plus 0.4599. You're getting 0.9599. So this is our answer for this one. Thank you for watching. Sorry, we have not finished. Let me clean the board. Jesus, sorry, I made mistake. I told you that this curve will be asymptote about the horizontal. So let me clean. So we have between 8 and 12. That's the IV. So it will be probability between 8 and 12. This is how you are going to represent it. So we'll be having probability x is 8 minus our mean, which is 5, all over standard deviation, which is 4, is less than or equals to z less than or equals to 12 minus 5 over 4. So we have probability of 3 over 4 will give us what? 0.75, right? Is less than or equals to divided by 4. Give us 1.75, right? So let's represent this. We have our curve that is symmetric, right? 0.75. Wow. It will be somewhere here. So we have 0.75. Then 1.75 will be somewhere here. We have 1.75. These are 0. So this place, this is where we are looking for. This is the area where we are looking for. So what are we going to do? It's very simple. So it will be P of Z is equals to 1.75, then minus P of Z is equals to 0.75. That's what you're going to do. So minus this one. So we're going to have 1.75, 1.7 under 5, 0.4599, 0.4599 minus 0.7 under 5. 0.2734, 0.2734, and subtract 0.4599 minus 0.2734 will be giving us 0.1865. So that's our answer for the IV. I hope you can see it. So that's our answer. Now the last one, which is the V, exactly 15 hours. You know that when you have your probability that the Z is equals to this thing. Okay, let me represent this on this table so that you understand what I'm saying. For example, I have a point here A, I have another point here B. If you still remember what we said in normal distribution table and the curve, that if we are looking for the probability of what? A, the probability of what? For example, that our x is equals to A. The probability of x is equals to A is what? 0. That this is the height we only have our height. We don't have the range of what x, the value of the ranges of what x. So if you're having just probability that x is equals to a, we don't have any ranges, was 0. Same thing applicable to b. So probability that z is 15 is equals to what? 0. So that's the answer. So thank you for watching, and may God bless you. Bye bye.